Good morning, students. So I'm Brinita Pinto. Today I'll be going through the problems of transformers. So we will be seeing the first set of problems where we will be solving the problems on finding out the primary and the secondary currents, the voltages, maximum value of the fluxes, and the number of turns. So the second set of problems will include calculation of the losses and the efficiency. So for today we will go through the first set of problems. So let me go to the first problem. A 200 kVA 10,000 volt slash 400 volt 50 Hz single phase transformer has 100 turns on the secondary. Calculate the primary turns, the primary and secondary currents, maximum value of the flux. So first, let us see what data is given in the problem. So you can see it is given that it is a 200 kVA transformer. Now what do you mean by this kVA? If you remember, I had explained you about the apparent power. So if you remember, apparent power is nothing but the product of the circuit voltage and the current without the reference to the phase angle. So kVA is nothing but the product of voltage and current. So product of voltage and current will give you the apparent power, and the unit of apparent power is kVA. Next we have 10,000 volt slash 400 volt. So if you see this is nothing but the primary voltage and the secondary voltage. So primary voltage is 10,000 volt, this is nothing but V1. Secondary voltage is 400 volt, this is nothing but V2. Next you have 50 Hz given, so this is nothing but the frequency. Then you have 100 turns on the secondary, that is nothing but N2. Now what do you have to calculate? Primary turns, that is N1, primary and secondary currents, that is I1 and I2, and maximum value of the flux, which is given by phi m. So let's go to the problem. So whenever you solve a problem, it is ideal or it is better to write what is given and what do you have to find out. So this will make easier to find out the solution for a problem. So I have written the given details first. I have also written what details that we need to find out. If you go back to your basic principle of the transformer, in the basic principle of the transformer we have deduced a relationship. V2 by V1 is equal to N2 by I1, N1 is equal to I1 by I2. So I have written this relationship here. V2 by V1 is equal to N2 by N1 is equal to I1 by I2. Using this relationship we will be solving the problem. So let me take here. First, what do I have to find out? I need to find out what is the number of primary turns. So which formula can I find out? Can I go with this formula? So if you see here, V2 is given 400 volts, V1 is given 10,000 volts, N2 is given which is 100, N1 is the one which we need to find out. So clearly you can use this formula. So using this formula we are going to solve the problem and finding out the N1. So this is what you are going to do. Next we need to find out what is the primary current I1 and I2. How are you going to find out? I've already told you that in the problem we have got the apparent power of the transformer. So they have given that it is a 200 kVA transformer. You can see here up in the problem it is given that it is a 200 kVA transformer. So let me come down. So apparent power is nothing but product of voltage and current. So V into I gives you the apparent power in kVA, now which is nothing but equal to 200 kilovolt ampere. So V into I is equal to 200 kilovolt ampere. Let me take it. So 200 kilovolt ampere is equal to voltage into current. Now since I'm going to find out the primary current, let me use V1 into I1. So 200 kVA is equal to V1 into I1. V1 is nothing but 10,000 volt, which I have already substituted. I1 is the one which I have to find out. So this is how I am going to find out I1. Similarly, let me go to the secondary current. Let me use the same formula. 200 kVA is equal to V2 into I2. Since I am going to find out the secondary current, let me use the secondary voltage 400 volts into I2. So this is nothing but using the same formula. So V2 into I2 is equal to kVA for your secondary current. So this is how you are going to find out I2. Next, they have asked us to find out what is the maximum flux. So if you remember the transformer EMF equation, so you had derived a transformer EMF equation, E is equal to 4.44 F into N into phi m. So if you have to find out the EMF of the secondary, then you need to use E2 is equal to 4.44 F into N2 into phi m. If you want to find out the EMF of the primary, then use E1 is equal to 4.44 F into N1 into phi m. Now, since phi m is constant, I can either use E1 equation or E2 equation, since both the equations will lead me to the same answer. Now I have used a E2 equation here. You can also use the E1 equation. E1 is equal to 4.44 F into N1 into phi m. Let me use the second equation. Phi m. So using this equation, I have to find out what is phi m. So phi m will be equal to E2 divided by 4.44 F into N2. So let me substitute that. 4.44 F is nothing but frequency, N2 is nothing but 100. What is E2? E2 is nothing but it is given as 400. So let me find out the maximum flux. So this is how we are going to find out the maximum flux. Now please make sure you write the units everywhere. The unit of flux is Weber. So please remember to write the units. So we have solved the first set of problem. So this is one kind of problem where you will be given certain details like this. So always remember to write what details are given and what details you need to find out. This will make it easier for you to solve the problem. So in the first set of problems, we mainly use only two set of equations to solve the problem. One is this: V2 by V1 is equal to N2 by N1 is equal to I1 by I2. The second set of equation that we will be using for this set of problems is EMF equation, that is E1 is equal to 4.44 F into N1 into phi m, or E2 is equal to 4.44 F into N2 into phi m. So we have solved the first set of problems. I hope it is clear. Let me go to the second problem. The second problem: a single phase transformer with 10:1 turns ratio and rated at 25 kVA, 1200/120 volt, 50 Hz is used to step down the voltage of a distribution system. The low tension voltage is to be kept constant at 120 volt. Find the value of the load impedance on the low tension side so that the transformer is fully loaded. Find also the value of maximum flux if the low tension side has 25 turns. So let me see what details are given now. So clearly they have given that the transformer is rated at 25 kVA. Next they have given me the primary and the secondary voltage. 1200 is the primary voltage, 120 volt is the secondary voltage, 50 Hz is the frequency. Now they have clearly told you that the transformer given is a step down transformer. What is a step down transformer? What does the step down transformer do? Step down transformer will lower the voltage. That is, the secondary voltage will be less than the primary voltage. Next, the low tension voltage. They have given you it is the low tension voltage is to be kept constant. Now which is the low tension voltage here? If you clearly see here, if you see this primary and the secondary voltage, it is clearly visible that the low tension voltage is nothing but the secondary voltage, which is equal to 120 volt. Now they have asked you to make sure that this 120 volt is kept constant. Next, find the value of the load impedance on the low tension side so that the transformer is fully loaded. So you have to find out the load impedance. What is that you have to find out? Z. On the low tension side, that means on the secondary side, so you need to find out Z2. Find also the value of maximum flux, so you need to find out phi m. If the low tension side has 25 turns, which is the low tension side? Clearly the secondary side. So secondary side in the sense N2 will be equal to 25 turns. So this is what I've clearly mentioned here in the given. Now what do you have to find out? Load impedance on the low tension side, Z2, phi m, that is the maximum number of flux, and the given number of turns is 25 turns. How can I find out? If you remember this equation, V is equal to I into Z. Using this equation, I am going to find out what is the load impedance. So since I have to find out the load impedance on the low tension side, let me use V2 is equal to I2 into Z2. So V2 is given. What is I2? I2 is not given. That means you need to find out. Z2 is the one which you need to find out. So first I need to find I2, then I can go to find out load impedance Z2. Let me find out I2. Let me follow the same procedure that we had followed in your first problem. So what did we do? They have clearly given you the apparent power, which is given in kVA. Apparent power is nothing but the product of voltage and current. So V into I is equal to 25 kVA. So what happens? 25 kVA divided by V2 will give you I2. This is what I have done. 25 kVA divided by V2. So this gives you I2. So once you get the current I2 on the secondary side, you can substitute in this equation and directly find out what is the load impedance Z2. So this is what we have. So you need to do this. Z2 is equal to V2 by I2. Once you find out the load impedance, then you need to find out what is the maximum flux. So I've already told you, you can either use the E1 equation or the E2 equation. Both will give you the same answers since phi m is constant for both. So I have used E2 equation here. So again, following the same procedure, phi m is equal to E2 divided by 4.44 F into N2 equal to 120 divided by this. Phi m is equal to 120 divided by 4.44 F into N2 equal to 120 divided by this. Phi m is equal to 120 divided by this. Phi m is equal to 120 divided by 4.44 F into N2 equal to 120 divided by this. Phi m is equal to 120 divided by 4.44 F into N2 equal to 120 divided by this. Phi m is equal to 120 divided by 4.44 F into N2 equal to 120 divided by this. Phi m is equal to 120 divided by 4.44 F into N2 equal to 120 divided by this. Phi m is equal to 120 divided by 4.44 F into N2 equal to 120 divided by this. Phi m is equal to 120 divided by 4.44 F into N2 equal to 120 divided by this. Phi m is equal to 120 divided by 4.44 F into N2 equal to 120 divided by this. Phi m is equal to 120 divid 0.021 Weber. Let me go to the third problem. Find the number of turns required on the high tension side of a 415 240 volt 50 Hz single phase transformer if the area of cross section of the core is 25 cm square and the maximum flux density is 1.3 Weber per meter square. So first find out what is given. So what do you have to find out and what data is given? Find the number of turns required on the high tension side. That means you need to find out the number of turns. Now see here, which is the high tension side? If you can see 415 240 volt. Clearly 415 is the high tension side, that is nothing but the primary side. So you need to find out the number of turns on the primary side. That is N1. Frequency is given 50 Hz. Area of cross section of the core, that is nothing but A, is given, which is 25 cm square. Maximum flux density, that is nothing but B, is given 1.3 Weber per meter square. So this is what I have written the given. Now note this. If you clearly see here, area of cross section is given in centimeter square units. Maximum flux density is given in meter square units. Now whenever you are solving a problem, make sure all the units are in the same. All the units are same. Now since this is centimeter square, this is meter square, I need to convert this 25 centimeter square to meter square. How do I do that? Now A is equal to 25 centimeter square. So what is centi? Centi is nothing but 10 to the power minus 2. So 25 into 10 to the power minus 2 square into meter square will give you the answer of area of cross section in meter square units. Now I can use this in the equation. Now which equation can I use? If you see here, V1, V2 is given, so I can take it as E1, E2, F is given, area of cross section is given, maximum flux density is given. Which formula can you use? If you remember the transformer EMF equation problem, the transformer EMF equation derivation. There clearly we had derived this equation, E1 is equal to 4.44 F into N1 into phi m. Now what is phi m? Phi m can also be written as phi m is equal to Bm into A, where Bm is nothing but the maximum flux density, A is nothing but the area of cross section of the core. So substituting that, let me find out N1. So E1 is equal to 4.44 F into N1 into Bm into A. So substituting that in this equation, we will get the number of turns of the primary. I hope it is clear by now. How do you use the equations here? So clearly, as I told you, you have got only two set of equations to be used in the first set of problems. That is nothing but V2 by V1 is equal to I2 by I1 is equal to V2 by V1 is equal to N2 by N1 is equal to I1 by I2. Another set of problem is the EMF equation, which is E1 equal to 4.44 F N1 into phi m and E2 is equal to 4.44 F into N2 into phi m. Now let me go to the fourth problem. Now this problem you need to solve. I'll tell you what you need to do, but you have to solve this. The required no load ratio in a single phase 50 Hz core type transformer is 6250 volt. Find the number of turns per limb on the high and the low voltage sides if the flux is to be about 0.06 Weber. So what is given? E1 is given, E2 is given. Fine. F is given. You need to find Number of turns on the high and the low voltage sides, that is N1 and N2. Flux is given. Clearly you can see, you can use this formulas. E1 is given, F is given, N1 you need to find out, phi m is given. Now for the secondary, E2 is given, F is given, N2 you need to find out, phi m is given. So this is for you to solve. I have already told you what you need to do. This is for you to solve. Let me go to the fifth problem. A 125 kVA transformer has a primary voltage of 2000 volt at 60 Hz. Primary turns are 182 and the secondary turns are 40. Neglecting losses, calculate no load secondary EMF, full load primary and secondary currents, flux in the core. Now what do you have to find out? No load secondary EMF, which is secondary EMF, that is nothing but E2. Full load primary and secondary currents I1 and I2, flux in the core phi m. What is given? Apparent power is given 125 kVA, primary voltage is given 2000 volt, frequency is given 60 Hz, primary turns N1 is given 182, secondary turns are given, that is N2 equal to 40. Now let me go to the solution. What do I have to find out first? E2. Which equation can I use? Can I use E2 is equal to 4.44 F into N2 into phi m? Can I use that? No. Why? Phi m is not given. How will you do it? Next, go to the second set of problem. That is E2 by E1 is equal to N2 by N1. Clearly, E2 is the one which you need to find out. E1 is given, that is nothing but 2000 volt. N2 is given, N1 is given. Clearly you can find out E2. So you have got the answer for the first question. Next, I1. How do I find out I1? Clearly in your problem apparent power is given, that is nothing but 125 kVA. Voltage is given, primary voltage, secondary voltage you have found out here. That means you can find, using the primary voltage you can find out the primary current, using the secondary voltage you can find out the secondary current. Same as before. Let me go to the third question. That is nothing but you need to find out the maximum flux. As already explained before, you can either use the E1 equation or E2 equation. Here I have used the E1 equation. Using the E1 equation I need to find out this what is phi m. So let me find out what is phi m from this equation. So phi m is equal to E1 divided by 4.44 F into N1. Substitute, you will get the answer for maximum flux. So students, this is the first set of problems where you will be using two simple equations, that is E2 or V2 by V1 is equal to N2 by N1 equal to I1 by I2. That is the first set of equation. Second set of equation is this EMF equation, E1 equal to 4.44 F N1 phi m or E2 equal to 4.44 F into phi m. Thank you.